Hello and welcome back to the DSA course where I am continuing my ongoing series about explaining data structures and algorithms. In the last video we discussed about the binary search special problem about the infinite array and how to search and how to apply the reverse application of binary search to find the target in the infinite array. In this video we will be going onwards and I wanted to start with the applications about sortings. So we will be covering binary search in later videos where I solve some specific problems related to it, but yeah, we can start with the sorting for this one. So mainly there are 5 types of sorts that are possible that we can apply, and each one having its own time complexities and its applications. So let's name them all in brief for a while, for a minute, and then we can start with the first one, the explanation about the first one. So the very first one is the bubble sort. The second one is selection sort. The third one is cyclic sort. Fourth being merge sort. This one actually is quite popular, and the last one being insertion sort. Alright, so when we talk about sorting, basically what we want to do with our array or anything, any given input, is basically sort in ascending or descending order, right? So either we want to do it in descending order or in ascending order, right? So what the main purpose that sorting brings to anything is that when we apply it, the order of the elements will be changed, right? That is obvious, because let's say we are given some array like 7, 1, 3 and 5, and we are asked to sort it in both ways, So let's go with the ascending one. The ascending would look like 1, 3, 5 and 7, right? And the descending one would look like 7, 5, 3 and 1. Now if you can notice or not in this one, that in the ascending one, all the elements before 7, meaning 1, 3 and 5, are already sorted in the original array. We are already doing that, we are already given the array like that, and we are asked to sort it in ascending order, and we can see that 1, 3 and 5 already sorted. So here's where all the applications of each of sorting comes. That's why I said that each sorting has a different application, and we will be covering each one in depth. We'll be solving problems about each. So and we will be covering each and every one, starting from their complexity to space complexity and to its application, right? So let's start with bubble sort. We will be going with, by the way, the order of which how I explain each of these 5 will be a bit delayed, because I can't explain the merge sort and insertion sort right now. All 5 can't be explained at this moment, because these two use the application of recursion, right? I can't exactly explain merge sort and insertion sort without the understanding and application of what and how recursion works. So we need to understand what is recursion, how recursion tree, how decision making trees, how selected and unselected the process of that works, how stack memory works when we use recursion. So we will be covering that when we understand the recursion, understand its applications thoroughly, right? So we will be going through bubble sort, selection sort and cyclic sort right now, right? One by one when we talk about sort, right? So let's go in with bubble sort. All right. So bubble sort, basically what the meaning of bubble sort means and why is it called bubble sort. So exactly it's not like a bubble, but we can say that it somehow manages to respect its name. So let's say we are given an array 1, 10, 8, 5 3 and 2. Alright, and we are asked to sort it in ascending order. Will we, by the way, in each question we will be taking the primary sort order as ascending only. We will discuss about descending, but it's basically exact opposite about what ascending means, right? So we will just reverse the application. I'll cover that part as well. So let's say always, by the way, how the thinking should work when we talk about sorting. So let's give the output of what we want the array to look like when it's sorted, right? So we want the array to look like 1, 2, 3, 5, 8 and 10. This is how we want the array to look like. Now we can see that 1 is in exact that position, but 2, it came from the very last index, which is n, right? We are starting from 0 to n. So we can say that we are saying that 2 came from the last position. Now what the application of bubble sort, how the way bubble sort works is that in every, we run the loop for one time from start to end, which is 0 to n, right? The main loop runs from 0 to n. The main loop we will iterate with I times, so I runs from 0 to n, and within that we run another loop. Let's say it's iterating with the element j, so j will run from 1 to n times. Now why 1 to n times? Why are we not taking 0 to n times, right? Because we already did that for I. So doesn't that make sense? If we again wanna iterate the loop again, then why not again go for 0 to n? But no, I'll explain that part. So inside the loop we are taking the j, which is running from 1 to n times, and each time this j element is going to be compared with the element that is before it, right? So let's say that this is the array, and we are covering and we are comparing every time that j runs, we are comparing that whether array of j is greater than array of j minus 1. J minus 1. So basically what this means is that in here, in the first iteration, this is the I, right? This is the I, and each time when j runs, it will start from 1, right? This is 0 and this is 1. So each time when j runs, it will compare the first element with the 0 element. Means in the first one, because I am starting from 0. So it will compare the element and the element before it every time. Now that's why we are taking j from 1. This is why we are taking 1, because we are comparing the element before it. So for the very first time we have to compare it with the element before it, right? So that's why we are taking j as 1. It will start from 1 because it needs to be compared with 0th element, and for that we need to take it with 1. So that's why. So in the first round 1 will be compared with 10, and we are saying that 1 is less than 10, right? That's what we are doing, that if array of j, which is basically this one, this is the one, then is greater than 1, yeah it is, so then we do nothing, right? But if that is not the case, because we are basically going to swap it every time if we find this condition as true, if this condition is true, then we are going to swap this. How? That this element of j is now going to be element of j minus 1, and the element of j minus 1 is going to be element of j. So basically swapping if we find that condition, right? So let's say 10 is greater than 1, right? So that is correct. Now j will and by the way j will go every time, j plus plus every time, right? So here we do nothing because 10 is actually greater than 1, right? Then what happens? J plus plus. So now j is going to be 8, right? 8 will be compared with 10, right? If 8 is greater than 10, but no, that is not the case. So like I said, if that is not the case, then j and j minus 1, those elements will be swapped. So basically 10. So how it will look in j is equals to, when j is equals to 2, we started from 1, right? So when j is equals to 1, it will be 1, 10. When j is equals to 2, 1, 8 and then 10. This is how it will look, because we are swapping 8 and 10, because it violates, because it actually satisfies this condition. When it satisfies this condition, it will be swapped, right? So when j is equals to 3, means when j is equals to 5, it will be compared with this one. It will not be compared with 8. It will now be compared with 10, because we swapped it with 8. So is 5 greater than 10? No, 5 is not greater than 10. So when j is 3, then it will again be swapped. So 1, 8, 5, 10. Now and like just like that, it will be compared with every element till it reaches n. So when j is n, this 10, we know from the array that this 10 is the highest. So if you can see if you can spot the pattern, you are seeing that every time j iterates from 1 to n, this 10 is getting shifted by one place, meaning the highest element in the array is shifting by one place. So when j is equals to n, it will be 1 and something, and then the last element is 10. The last element will be 10 at the end of the array. So basically how it will look like, all the elements in the original array, I'll write the original array after the first iteration of I. It will look something like this: 1, 8, 1, 8, 5, 3, 2, 10. 10 was originally here, it came to here when I is equals to 0, means I 0 to 1. When we are transitioning, when we are iterating in the very first time, we can see that the very topmost, means the highest most element, is getting shifted to its actual place, meaning now 10 is in the correct place. We can see we are sorting it in ascending order, right? And the highest element is now at its correct place. That is also correct. Similarly, this ith loop, I iteration, will run until n times, and in every time we are checking j with its previous element, whether if it's true that j is greater than the last element, then we are swapping them. And if it's not, then we simply don't do nothing. We iterate j with plus plus. We are checking j again with the next element. If it is greater than its previous element, then we swap. If it's not, then we simply go j plus plus. So every time I will go on to n, the highest element will go to correct place. That is correct. We saw 10 is in the correct place after the first round. What's the second most highest element? 8. When I is equals to 1, it will be something like 2 and all will be shifted one place with 8, 10, 2, 3, 5 and 1. It will be something like this, and so on and so forth. Then 5 will be swapped with 2, then not swapped exactly. So 5 will come at its correct place, then 3 will come its correct place, then 2 will come, and then 1 will come. So basically every time the outermost loop is running, the topmost element, the highest most element in the array is getting placed in its correct position. So if we write this all in a code, we are saying that for I is equals to 0, I less than n, I plus plus, and inside this we are going with j, which is not 0, which is 1. J is equals to 1, j less than n, j plus plus, correct. If j is greater than j minus 1, then we simply swap it. And if it's basically very simple how to swap it, we make a temp is equals to j, and then j acquires the position, the value of j minus 1, and then j minus 1 acquires the value of temp. This is basically a very simple temp swapping value. It's not that complex. And if it's nothing, means if j is greater than j minus 1, right? So we only swap when it's greater than its previous element, otherwise we don't do anything. So we come out of this for loop and the other for loop. Now if you can see, this loop is running one time, there is one for loop, there is second for loop. Now the time complexity of this way of sorting is going to be n, big O of n square, right? Because we are actually going two loops, a loop within a loop. An entire loop will run when the outermost loop runs ith time, right? So j will run n times, and I will run n times. Is there any way to optimize this thing? Yes, there is. This is the brute force. We can use an optimized version of brute force. It still uses n square, but we can kind of optimize this one. To optimize it in a bit more way, we can use, for that let's go to the whiteboard. Let's say, so when I is 0, right, when I is 0, 10 is going to its correct place, right? That is correct, we saw. When I is 1, the second most element, the second highest element after the highest, which is 10, so the 8, which is the second most element, is getting placed to its correct position. That is correct. We notice that it is getting sorted from right to left, right? From right to left. You can see that every time when j completes its one iteration, means when I completes its one iteration from 0 to n, the rightmost elements are getting sorted in its order, right? And in the code we saw that we are running from j less than n here. Now, do we need to do that every time? Do we need to run the jth loop till n every time? Because we know that running till n every time, and we are checking all the sorted elements again. See, in the when I is 1, these two elements are already sorted, right? So when I is going to be 2 time, I is going to be 2, these two elements will already be sorted, right? So why are we again going till n times for j? We don't even need to go till the end every time. For the very first time it will go till end because it needs to place the topmost element to its right position, which is the end. But why are we going every time till n? So we can optimize this condition. We don't need to make it go till n. Every time we need to subtract it by some value, right? We are subtracting one time for when I is 1. We are subtracting it 2 times. See the pattern over here. We subtracted 0 times because 10 needs to be going till the end. So the I runs till n. We are subtracting it. We don't need to go till 10 in the first iteration. So when I is 1, we don't need to go till the last element. We are going till the second last element. When I will be 2, we don't need to go to the second last element. We will stop till third last element. So you can see the pattern, right? We need to subtract the j less than n by I times when it goes down, right? So this condition we can optimize it a bit, j less than n minus I. What this will do for us is that when the I is n minus 1, j will only run till the first element because it needs to sort only that much part of the element of the array. It doesn't need to go till the end because all that part is already sorted. We are already going it every time. We are already sorting those parts every time. So why even go till that far? It's just waste of time, right? So that's why we are going for n minus I. J will only run till n minus I times, and it will keep on reducing as the I keeps on increasing. Now let's optimize this one even a bit more because it still is big O of n square, right? We are still actually using 2 loops only, even though if it's optimizing the second inner loop, we are still using the 2 loops. Let's go for even a better option. This is a more of an intuitive one. Let's say we make a variable, a boolean variable called swapped right before the first right before these two loops. Here we make a variable called swept, which is false at the beginning, right? And here between these two loops, wait, not in this one, we can just bool swept before these two loops, right? Between these two loops, before the jth loop runs, we can declare it as false. And when the swapping happens, before the jth loop exits, we can turn that swept is equals to true, right? Now what this will confirm is that it is basically a switch. What I did right now is basically a switch. Introduce a swap variable between the two loops, and then I am turning that parity, means the false turns to true after it gets swept, right? This will happen every time, because when it enters the I is equals to 1, then it will enter this part. Here we are turning it false. When it gets swept, we are turning it true, right? So this will keep on switching. Now after these two loops end, when it goes again, now after this jth loop ends, we can always put a check over here that if not swept, then return. We don't need to do anything. We are basically breaking from the function. Now how do we understand this logic, right? We are basically turning swap false to true. And why are we turning it to true? Because we actually swap it. And why are we swapping it? When we find the element which is greater than its previous most element, right? That's why we are turning the swap equals true. And if at any point we check that swap doesn't get true, meaning this condition, this if condition, which is j is greater than j minus 1, doesn't gets true, then this block won't exist. And if this block won't exist, means this block won't run for that iteration of j, meaning swap won't be turned true. And if swap won't be turned true, then we are checking right after it that if it is not true, means it's false, then we are returning. Now what does this mean? Basically, if this block doesn't run, what does that say? That jth element is not bigger than its previous element. And when that happens, that only happens when the array is sorted. Now if the array is already sorted, we don't even need to continue sorting it. Let's say the array elements consist of 10 elements. Last 5 are sorted, only the first 5 needs to be sorted in its ascending order. So I will run 5 times. When we reach the 6th time, it will get into this logic. We won't even get into the swapped logic, because it will not even exist true for those 5 elements, because we are basically breaking it if swap doesn't happen. If swap doesn't happen, then it basically means that the array is sorted. Means that after the iteration of jth element, that part of the array will be sorted, because we don't need to check even more. If that part of the array breaks, means if you are breaking from here, it means it's sorted. All the elements after it will also be sorted, so we don't even need to go further beyond it. So basically that's how the logic works. Still, that doesn't change the fact that it will be O big O of n square. We just optimized it a little in terms of constant values. We are not completely going to iterate all the elements, but that doesn't change when we talk about the worst case scenarios, because the worst case scenario in this case, what's the best case? Let's talk about best case and the worst case. So the best case is that the array is already sorted, meaning if we are sorting in ascending order, then if it's given in ascending order, then it's the best case. If it's given in descending order, when we are asked to sort it in descending order, then it's the best case. What's the worst case? Let's say we are asked to sort the array in ascending order, and our array is something like 7 7 6 5 3 2 1. So basically this is descending order, right? So we need to change every element and every position of every element every time. So all the iterations in I will run and all the iterations in J will also run, because we are basically changing the entire array in its basically we are reversing the array. So this is the worst case for the ascending. If we are given an array, if we are going to sort the array in descending order and we are given it in ascending, then that's the worst case for the descending array. So basically the opposites, you get the idea. So, and basically let's talk about descending order. Everything remains the same, literally everything remains the same, only this logic will shift to descending order. Only that part changes. If the array is small, if that element is smaller than its previous element, then then if the if that element is smaller than its previous element, then we swap it. So basically all these signs will change accordingly, so nothing changes as much. So yeah, this was the bubble sort, right? So in the next video we will be talking about the selection sort and cyclic sort. So I hope you got the intuition and application of bubble sort. I hope you keep watching my videos and recommend changes if needed. I'd like some opinion on how to explain in more clarity. Alright, thanks. I hope you enjoyed the video and hope you understood the application of bubble sort. We will be talking about the selection sort and cyclic sort in the next videos. Thank you.